In this video, we will be introduced to the concept of failure modes. What is a failure mode? A failure mode refers to how an item or system might fail. It's not the consequence of the failure, but the way in which the failure occurs. This could involve physical degradation, mechanical malfunction, software bugs, or even human error. For example, in a pump, a failure mode might be seal leakage. This explains how the pump could fail, but not the effect of that failure, like fluid loss or system shutdown. Understanding failure modes is critical when performing failure modes, effects, and criticality analysis. MECA is a structured approach that helps us identify potential failure modes in a system, understand their effects, and assess their criticality. But why is this important? 1. Proactive risk management. Identifying failure modes allows teams to anticipate how and why a system might fail. With MECA, we can pinpoint the most likely failure modes and their potential impacts before they even happen. This proactive approach lets us implement solutions in advance, preventing costly downtime, damage, or safety risks. 2. Prioritization of critical issues. Not all failures are equally important. MECA helps us rank failure modes by their severity, frequency, and likelihood of detection. Understanding these modes allows us to focus on the most critical issues that can cause the most significant damage or pose the highest safety risks, enabling better resource allocation and decision-making. 3. Enhance safety and compliance. In safety-critical industries like aerospace, automotive, and healthcare, identifying failure modes is essential to avoid accidents. MECA ensures that we address high-risk failure modes, which is crucial for compliance with safety regulations and standards. Understanding failure modes helps us design safer systems, reducing the risk of catastrophic failure. 4. Cost efficiency and resource allocation. MECA enables teams to focus maintenance efforts where they matter most, on components or systems that are likely to fail and cause major disruptions. By knowing the failure modes, we can optimize maintenance schedules, mitigate risks, and lower costs by targeting the areas most prone to failure. 5. Continuous improvement and product reliability. Understanding failure modes through MECA allows companies to improve product design and system performance. By identifying weaknesses early, teams can make adjustments that enhance reliability and durability. This results in more reliable products, fewer breakdowns, and increased customer satisfaction. 6. Reducing downtime and increasing productivity. When failure modes are understood and accounted for, systems can be designed and maintained more efficiently. This reduces the chance of unexpected breakdowns, minimizing downtime, and ensuring higher productivity. MECA-driven improvements lead to smoother, more reliable operations across industries. Conclusion: understanding failure modes through MECA is essential for proactive risk management, improving safety, reducing costs, and driving continuous improvement. It's not just about identifying failures. It's about preventing them, prioritizing critical issues, and creating more reliable, efficient, and safer systems.